A very good morning, everybody. We are going to work with multi-threading in Java. Now, before we talk about multi-threading, first let us discuss threads. When we talk about a thread is a lightweight, smallest part of a process that can run concurrently with the other threads of the same process. Threads are independent because they all have separate path of execution. That's the reason. If an exception occurs in one thread, it does not affect the execution of other threads. Now, all threads of a process share the common memory. The process of executing multiple threads simultaneously is known as multithreading. Proceeding further, the main purpose of multithreading is to provide simultaneous execution of two or more parts of a program to maximize the utilize of CPU time. Maximize the CPU time. A multi-threaded program contains two or more parts that can run concurrently. Each such part of a program is called thread. Threads are lightweight subprocess. They share the common memory space. Now in multi-threaded environment, programs that are benefited from multi-threading utilize the maximum CPU time so that the idle time can be kept to minimum. Now, proceeding further, let us have a look to the different states where how the threads go through. When we have a new thread, that means a thread that has not yet started in this state. A newly created thread that is in the new phase or new state. Runnable. When you talk about runnable thread, a thread executing in Java virtual machine is in this state. Blocked. A thread that is blocked, waiting for a monitor lock is in this state. That means it is waiting for the execution and wants to be executed or its process have been stopped. Waiting. A thread that is waiting indefinitely for another thread to perform a particular action is in this state. Timed waiting. A thread that is waiting for another thread to perform an action for up to a specified waiting time is in this state. Terminated. A thread that has exited is in this state. A thread can be in only one state at a given point of time. Proceeding further, let us have a look to about what is multitasking, multithreading, multiprocessing and parallel processing. Talking about, if you are new to Java, so you might get confused among these terms. So we have quietly explained this now. Talking about multitasking, it is the ability to execute more than one task at a time is known as multitasking. Multithreading, as we have already discussed, it is a process of executing multiple threads simultaneously. And multithreading is also known as thread-based multitasking. Multiprocessing, it is the same as multitasking. However, in multiprocessing, more than one CPUs are involved. So, on the other hand, one CPU is involved in multitasking. Parallel processing, it refers to the utilization of multiple CPUs in a single computer system. Now, how do we create a thread in Java? There are two ways of creating a thread in Java: by extending thread class, by implementing runnable interface. Now, before we begin with the programs or the course of creating the thread, let us have a look to these methods of thread class. We have used few of these methods in the example below. Now, get name. It is used for obtaining a thread's name. Get priority. It is used to obtain thread's priority. Is alive. Determine if a thread is still running. Join. Wait for a thread to terminate. Run. Entry point for the thread. sleep, suspend a thread for a period of time, start, start a thread by calling its run method. Now the first method, thread creation by extending thread class. Now you can see that we have class multi-threading demo that extends thread. Then we have the public void run system.out.println. My thread is in running state. In the main function we have public static void main string args multi-threading demo obj new multi-threading demo obj.start. Now this is, you can see the main function. We have created the object. Now calling the function object to start obj. Now then it is going to go for start. Now check about the starting a thread by calling its run method. So now we are going to call its run method. Now when we call the run method, it is going to read this line. So reading it, to a particular part. When we execute this program, we get my thread is in running state. Let us have a look to the second example now. We have class count which extends the thread. Then we have a function count. In this we have super, my extending thread. System.out.println, my thread created. Stop. Now proceeding further, we have the void run function, void run method. In this we have a for loop. For int I equals to 0, I less than equal to 10, I plus plus. Then system.out.println, printing the count, thread.sleep 1000. Now in the catch method, that means in the try method, then we have the catch method. Interrupted exception, E, system.out.println, my thread interrupted. System.out.println, my thread is run is over. Then we have another class extending example, public static void main string args, count equal to cnt, new count. Then we have try method. In the try method we have while loop, cnt dot is alive. That means we have to check it, is it alive or not. Then system.out.println, main thread will be alive till the child thread is live. Thread.sleep 1500. Now in the catch part, that means main thread is interrupted. System.out.println, main thread is interrupted. Then we have system.out.println, main thread run is over. Now proceeding further, when we execute this, we get the output. After proceeding further one by one, my thread created, thread, my runnable thread 5 main, which we get it from here. This is the entire program which will be running as per the loop, which you can see that we have about the loop over here running from I from 0 till 9, because it is less than 10. So it will be running from starting from 0 till 9. Then we have the another thread creation by implementing runnable interface. Now talking about this, then we have a very simple example in this. Class multi-threading demo implements runnable public void run system.out.println, my thread is in running state. Public static void main string args multi-threading demo obj new is equal to multi-threading demo thread t obj equals to new thread obj t obj.start. When we execute this program, then we get my thread is in running state. Now let us have a look to the another example. Now observe the output of this program and try to understand what is happening in this program. Now if you have understood the uses of each thread method, then you should not face any issue understanding this example. Now class count implements runnable thread myThread count. MyThread equals to new thread this dash my runnable thread. System.out.println my thread created my thread.start. Then we have public void run method in this. In this we have try for int I equals to 0, I less than 10, I plus plus. That means the loop will be running from 0 till 9. Now system.out.println printing the count plus I thread.sleep 1000. Catch interrupted exception E system.out.println my thread interrupted. System.out.println thread run is over. Class runnable example. Now public static void main string args count cnt equals to new count. Try while cnt.mythread is alive. System.out.println main thread will be alive till the child thread is live. Thread.sleep 1500. Catch interrupted exception E system.out.println main thread interrupted. System.out.println main thread is over. Now when we execute this program, then we get the output. My thread created thread, my runnable thread, dash 5 dash main. Main thread will be alive till the child thread is alive. Printing count 0, then 1. Main thread will be alive till the child thread is alive. Then printing count 2. So this will be running till the value of I in the loop reaches 9. So when it has reached 9, then we say my thread run is over. Now let us have a look about thread priorities. Now thread priorities are the integers we decide how one thread should be treated with respect to the others. Thread priority decides when to switch from one running thread to another. Process is called context switching. A thread can voluntarily release control and the highest priority thread that is ready to run is given the CPU. A thread can be preempted by a higher priority thread no matter what the lower priority thread is doing. Whenever a higher priority thread wants to run, if it does. Now to set the priority of thread, set priority method is used, which is a method of the class thread class. In place of defining the priority in integers, we can use minimum priority, norm priority or max priority. Now method is alive and join. Now in the practical situation, main thread should finish last, else other threads which have spawned from the main thread will also finish. To know whether the thread has finished, we can call is alive on the thread which returns true if the thread is not finished. Another way to achieve this by using join method. This method when called from the parent thread makes parent thread wait till child thread terminates. These methods are defined in the thread class and we have used isAlive method in the above examples too. Talking about synchronization, when we talk about synchronization, that means we are matching the timing. Just like I would like to tell you that when we use ATM, when we talk about ATM, that is referred as asynchronous transmission mode. ATM, asynchronous transmission mode, which specifies that at a single point of time, no two transactions can be done. This is what ATM speaks about. Now talking about the multithreading, multithreading introduces asynchronous behavior to the programs. If a thread is writing some data, another thread may be reading the same data at that point. This may bring inconsistency. When two or more threads need access to a shared resource, there should be some way that the resource will be used only by one resource at a time. The process to achieve this is called synchronization. To implement the synchronous behavior, Java has asynchronous method. Since a thread is inside a synchronized method, no other thread can call any other synchronized method to the same object. All the other threads then wait until the first thread come out of the synchronized block. When we want to synchronize access to objects of a class which was not designed for the multi-threaded access, and the code of the method which needs to be accessed synchronously is not available with us. In this case, we cannot add the synchronize to the appropriate method. In Java, we have the solution for this. Put the calls to the methods which needs to be synchronized, defined by this class inside a synchronized block in the following manner. Synchronize object statement to be synchronized. Talking about inter-thread communication, we have few methods through which Java threads can communicate with each other. These methods are wait, notify, notify all. All these methods can only be called from within a synchronized method. To understand synchronization, Java has a concept of monitor. Monitor can be thought of as a box which can hold only one thread. Once a thread enters the monitor, all the other threads have to wait until that thread exits the monitor. Wait tells the calling thread to give up the monitor and go to sleep until some thread enters the same monitor and calls notify. Notify wakes up the first thread that called wait on the same object. Notify all wakes up all the threads that call wait on the same object. The highest priority thread will run first. This is all about thread and multi-threading. In our forthcoming chapters, we are going to discuss process versus thread, thread life cycle, and daemon thread.